You probably believe that there is a backup planet for humanity, that somewhere, tens or hundreds of light years from here, there is a second Earth waiting for us. If we destroy this planet, we have a plan B. Today you will discover the truth that science knows, but no one wants to face. Welcome to the documentary that will destroy one of humanity's most comfortable fantasies. Because of the 5,600 exoplanets catalogued to date, none, literally none, have been confirmed as genuinely habitable. Start here. Earth, the only planet confirmed to be habitable in the known universe. Around us, 7 neighbors, all inhospitable. Venus, 462 degrees Celsius on the surface. Mars, atmosphere with 1% of Earth's density. The gas giants? Impossible. The closest star, Proxima Centauri, is 4.24 light-years away. That's 40 trillion kilometers. With our fastest technology, the Parker Solar Probe, it would take us 6,300 years to get there. The Milky Way has between 200 and 400 billion stars. Statistically, there may be billions of rocky planets in habitable zones. But there may be is not the same as confirmed, and that's where the problem lies. When you read NASA discovers habitable planet, what really happened was this. A telescope detected a microscopic drop in the brightness of a star, sometimes as little as 0.001%. This happens when a planet passes in front of it, blocking part of the light. With this drop in brightness, we calculated the size of the planet. With repeated observations, we determine the orbital period. If the star wobbles slightly, we can estimate the mass of the planet using the radial velocity method. And that's it. Size, mass, orbit, everything else. The beautiful illustrations of blue oceans, mountains, bright atmospheres, is artistic speculation based on mathematical models. We don't know the atmospheric composition of most. We don't know the actual surface temperature. We don't know if there is a protective magnetic field. We don't know if there is water. For 99% of the 5,600 catalogued exoplanets, we only know that they exist. And that brings us to the first candidate. 2015, NASA announces the discovery of Kepler 452b. Headlines around the world. Earth's cousin discovered. Planet most similar to Earth ever found. The facts. It orbits a G-type star like the Sun at a distance of 1,400 light-years. It is in the habitable zone. It has a diameter 6 times that of Earth. But here's what didn't make the headlines. With 1.6 times the size of Earth, Kepler 452b could have a mass 5 times greater. If the composition is rocky, the surface gravity would be twice that of Earth. Impossible for humans to live comfortably, but it could be worse. With that size, Kepler 452b could be a mini Neptune, a gas planet with a thick atmosphere of hydrogen and helium, without a solid surface. It is too far for detailed atmospheric analysis. Our spectral readings are inconclusive. 9 years after the discovery, we still don't know if Kepler 452b even has a surface where one can stand. First from Earth? Maybe. Or maybe a ball of toxic gas 1,400 light-years away that we will never be able to visit. 2016. Discovery that moved the world. A planet in the habitable zone of the star closest to Earth. Proxima Centauri b, just 4.24 light-years away. Minimum mass of 1.07 Earths. Orbital period of 11.2 Earth days. Theoretically, it could have liquid water, but Proxima Centauri is not the Sun. It's a red dwarf, small, cold, violent. In 2019, the ALMA telescope detected a stellar explosion from Proxima Centauri that increased its brightness 1,000 times in just 10 seconds. The ultraviolet radiation and X-rays released were equivalent to 100 billion megatons of TNT. Proxima b orbits just 7.5 million kilometers from its star, 25 times closer than Mercury is to the Sun. At this distance, each explosion of this type bombards the planet with radiation that would be lethal to any known form of life. A study from 2017, published in the astrophysical journal Letters, estimated that the radiation dose on the surface of Proxima b would be 250 times greater than that received by Earth. Without an extremely strong magnetic field, And we don't know if Proxima b has one. Its atmosphere would be gradually stripped away by stellar wind over millions of years. The closest potentially habitable planet could be a sterile radioactive desert. 2017. The discovery that broke records. 7 Earth-sized planets orbiting a single star, 3 of them in the habitable zone, 39 light-years away. This system has become the focus of hundreds of studies. The James Webb was pointed there. The hope was real. 2023. First atmospheric analyses from Webb. TRAPPIST-1b. No significant atmosphere detected. Probably a barren, rocky world. 2024. More results. TRAPPIST-1c. No evidence of a thick atmosphere. And here is the fundamental problem. TRAPPIST-1 is another red dwarf. These stars represent 75% of all the stars in the galaxy. They are the most common, but they are also the most problematic. Red dwarfs emit bursts of ultraviolet radiation and X-rays continuously, especially in the first billion years. The TRAPPIST-1 planets are so close to their star that TRAPPIST-1 completes an orbit in just 6 Earth days, and they are all tidally locked, the same side always facing the star. One hemisphere in perpetual light, potentially boiling, the other in eternal darkness, freezing. James Webb will continue observing for years, but until now, no confirmation of a substantial atmosphere, no detection of water, no signs of habitability. 7 planets, no second Earth confirmed. Habitable zone is the term you see in all the headlines, also called the Goldilocks zone. Not too hot, not too cold. Here is what this term really means. It's just the orbital distance where liquid water could exist on the surface if all other conditions are perfect. Venus is technically in the habitable zone of the Sun. Surface temperature, 462 degrees Celsius. Atmospheric pressure, 92 times that of Earth. Sulfuric acid rain. Not exactly the tropical paradise that the term habitable suggests. Being in the habitable zone requires liquid water on the surface. We only detected the most basic item, distance from the star. The rest, pure speculation. December 2021, launch of the most powerful telescope ever built. The James Webb cost $10 billion and represents 20 years of development. Your mission includes something revolutionary: transit spectroscopy to analyze exoplanet atmospheres. When a planet passes in front of its star, the starlight passes through the planet's atmosphere. Different molecules absorb specific wavelengths. Water absorbs infrared. Methane has its signature. Oxygen, another. In theory, we can detect the chemical composition of alien atmospheres. In practice, to analyze the atmosphere of a single Earth-sized exoplanet, Webb needs to observe multiple transits, sometimes dozens of them, over the course of months or years. Each transit provides a microscopic fraction of data. WASP-96b, a gas giant 1,150 light-years away. It took 6.4 hours of observation to confirm water vapor and clouds. It's a planet the size of Jupiter, easy to analyze. Planets the size of Earth have much thinner atmospheres. The signal is proportionally smaller. The analysis requires much more time. The Webb has thousands of observation proposals competing for time. Exoplanets are just a fraction. So far, out of the dozens of exoplanets analyzed by Webb, most are gas giants. No rocky planet the size of Earth has had its atmosphere fully characterized. And of the 5,600 most well-known, we managed to analyze spectroscopically fewer than 50, less than 1%. There are 5 main methods for detecting exoplanets. Transit method, 77% of discoveries. Requires the planet to cross in front of the star from our point of view. It worked for Kepler 452b, TRAPPIST-1, thousands of others. Limitation, it only detects planets whose orbits are aligned with our line of sight. Statistically, we miss 99% of the planets that exist. Radial velocity, 19% of the discoveries. Detects the gravitational wobble that a planet causes in its star. Limitation, favors massive planets close to the star. Small and distant planets produce wobbles that are too small to detect. Direct imaging, gravitational microlensing, timing, together less than 4%. And here is the fundamental limit. With current technology, we can only analyze relatively nearby planets in detail, within 100 to 200 light years. That is 0.0002% of the diameter of the Milky Way. It's like searching for life in the entire Pacific Ocean by examining just a drop of water. Statistically, there could be millions of Earths out there, but if we can't detect them, they might very well not exist. If you are starting to realize how the reality of space exploration is more complex and more fascinating than the headlines suggest, leave a like. There's much more hard truth coming, but science doesn't give up. NASA is developing the Habitable Worlds Observatory, an even more powerful telescope than Webb, specifically designed to characterize terrestrial planets. Expected release, the 2040s. In Chile, the extremely large telescope, with a 39-meter mirror, is under construction. It will be the largest optical telescope in the world when it is completed in 2028. Future projects include space interferometry, multiple telescopes working together to simulate an instrument the size of a football field. With these tools, humanity will finally have the ability to confirm or refute the habitability of nearby terrestrial planets. But that's decades in the future. And even when we have the technology to confirm a second Earth, it could be 50, 100, 500 light years away. The nearest star takes 4 years for its light to reach us. A manned spacecraft with current technology would take thousands of years. Interstellar travel is not impossible, but they are centuries beyond our current technological capability. Finding a confirmed second Earth does not solve the problem, because there's no way to get there. So we return to square one, this planet. This small blue dot. Liquid water in abundance, 71% of the surface. Oxygen-rich atmosphere, 21%. Strong magnetic field protecting against solar radiation. Perfect distance from the sun, 149.6 million kilometers. Average temperature, 15 degrees Celsius. Complex biosphere, 8.7 million estimated species. It is the only confirmed habitable planet within a radius of, well, within any radius we can observe, and we are systematically making it less habitable. The search for a Planet 2.0 has become a convenient distraction, a fantasy that allows postponing difficult decisions. Don't worry, we'll find another planet. No, we won't find it. Not in our lifetimes. Not in the lives of our great-grandchildren. And even if we find it, there's no way to get there. The search for habitable exoplanets is not useless. Far from it. Each discovery expands our understanding of the cosmos. Each planet studied teaches us more about planetary formation, atmospheres, and habitability. And perhaps eventually, it will answer the deeper question, are we alone? But while we look at the stars searching for a plan B, we must not forget that plan A is all we have. Confirmedly, scientifically, inevitably, there is no second Earth. There is only this one.